In today's lesson, we're going to come back to an old idea that we did way back when. We talked about rates, okay, the rate of buying something. You might recall we always put our money on the top and we'd buy, I don't know, 20 oranges for $7. And we'd say, oh, 7 divided by 20, it's going to cost us 35 cents an orange. Well, we're going to try and do the same thing, but we're going to try and find our rates in a different way now. We're going to start trying to find rates from looking at graphs. Graphs are a way of showing a relationship. Yeah, so let's start with the old idea, the one we know how to do. So we're going to go shopping for popcorn today. It's a theater. Should we buy a 200-gram bag of popcorn for $1.25 or a 750-gram bag for $4.50? Which of these is a better buy? Well, as we said way back when, take your money and you divide it by how many grams you get. And this one's going to cost us, and these are small numbers here, $0.00625 for 1 gram of popcorn. One kernel is going to cost you just that tiny bit of money. Well, if I want to compare it to the other one, I do the same process. And here we'll get $0.006 per gram. And then I ask myself, which of these is cheaper? Well, they're both pretty close, 0.006, but the next one has this little bit more than the other one. So this must be cheaper. It's a smaller value, which in our case is better, right? The more you get for the less the price, the better deal you've got. Well, I want to take this idea where I can compare different things at different amounts and find a rate to figure which is a better buy. But to do it, I want to get my information in a different way. So here's an example of how we can use a graph to do the same kind of information. This graph shows the relationship between the mass and the cost of different brands of jam. So brand A, if I read off the graph here, costs me $2.50 for 150 grams. So A is $2.50 for 150 grams. Well, that's the same information I was given previously in words, just getting it off the graph. If I try this one, I get $0.0166667 per gram. If I do the same thing with brand B, just estimating off my graph here, here's brand B, it's going to cost me, I'd say $2.25 for, I get 250 grams this time. And if I do my dividing there, I get $90.009 per gram. And we'll do the same thing with C. C, way over here, costs me $4.50 for 400 grams. 450 for 400 grams. I can do my dividing trick again, and I'll get 0.1125 per gram. And last but not least, let's try D. D is $4 for 500 grams, which gives us what, 0.008 per gram. The question was, which brand has the highest cost per gram? So I'm looking at these, I'm looking for the biggest number. In that case, I think brand A has the biggest of the three. They all start with a 0, but the next one, well, 1 is bigger than the next 0. So it gets rid of these two. And if I compare the next number, 1.6, well, that's bigger than 1.1. So the first one is brand A, the biggest. Now, who's to say we actually have to buy that much jam, right? If I think about brand A, really, this relationship is a series of dots that lead up from 0 to brand A. Well, if I stop and think about these lines for a second here, whichever one of these lines is actually the steepest has the highest rate. The steeper the line, the bigger the rate. Kind of an important idea we're going to talk about down the road. It's a way of figuring things out pretty quickly. So comparisons, not too bad to do. But often we don't really want to make comparisons. We just want to find the rate. And if I'm not given a single dot, just one dot, and instead I'm given a line, I can find that rate using a really kind of important idea. I call this rise over run. And the way this idea works is it's the difference between any 2 points on your graph. How do I get from the first point to the second point? So we're going to do some counting today. Okay? Rise goes up or down between 2 points. And your run is the difference when you go from left to right. We're always going to do left to right, okay? That's kind of a really big idea. The same way you read words is the same way you read a graph. So we'll start with a nice example here. The graph below shows a relation between the number of students going on a field trip and the cost. How much does it cost for each student? This is a fancy way of saying, find me the rate. I know that because it's basically cost per student. So we've always said the word rates, right? The word per. So let's give this a try. Rate. I'm going to do rise over run. But to do that, I need nice points. A nice point is one where I know the value of. For instance, this point right here I know is 10. Another nice point might be this one over here. Its value is 30 and 4, or 4 and 30. Okay, so I'm going to use these 2 points. To do my rise and my run, I have to draw a triangle. From my first point, up, and then over. Okay, so I'm going to go up. The question is how much? Well, I started at 10, and I finished at 30. So how much did I go up? I went up 20. And then I went over from 0 all the way to 4. Okay, so that's stage 1. Fill in the numbers from your triangle. How much did you go up? How much did you go over? Step 2 is to take these numbers and write them with units. 20 what? So 20 was my up and down, my cost. And 4 was my over, which is my number of students. And my last step is to actually do the dividing, like we did in the JAM question. 20 divided by 4 is $5 per student. The reason I had to do it this way, I couldn't just divide, is because I had a line instead of just a dot. Okay, so anytime we come across a line, we're going to do this idea of making a triangle. A really helpful thing. Okay, I'm going to try another one. The graph on the right shows how the height of a hot air balloon changes with time. Answer a series of questions this time. Part A. What is the balloon's initial height? Initial is just a fancy word for starting. What does the balloon start at? Well, I know that because the left side of my graph is where it starts, right there. It's at 250 meters. All right, what does the point A mean? Well, point A is right here. What's happening at A? I know that at 3 minutes, my balloon has reached a height of 220 meters. Okay, notice I read off the bottom first, the independent variable, and then went over to the side. Kind of the way we usually read graphs, we're looking at dots. Okay, part C, our big one. My rate. Okay, I need 2 nice points. Now I've given you kind of a clue in the first 2 questions here, which points to use. We're going to start the first point, the nice point that we definitely know, and we're going to finish at A. I'm going to do that by drawing a triangle. In my triangle, I have to go down, then over. Down how much? We went from 250 to 220, so that's down 30. So we're going to go down 30, that's the top. And then over, we went from 0 all the way to 3. Actually, sorry, I missed a word there. Over 3. And here's stage 1. Stage 2, let's fill in the units. 30 what? Well, those were 30 meters. This was 3 minutes. My last stage, let's divide it out. 30 divided by 3 makes 10 meters per minute. Now one more thing I'm going to add in here. This word down. It's pretty important. That means this is negative, which means this is negative. Signs are important. Anytime my graph goes down, I should have a negative rate. Which should make sense. The balloon's dropping over time. It's going down. Okay, last part, part D. What was the D question? Write the equation for the graph. Now we started talking about this a little bit yesterday. Every time we do an equation, we want x equals and y equals. X is the part across the bottom of your graph, the number of. In this case, the number of minutes. Y is always the second part of the graph, the up and down part. In this case, it's your height. Okay. Every equation is going to be the same. Y equals whatever you started at. Well, part A said, what did we start at? What was the initial height? It was 250. Okay, so this is always my initial. And then we do the, what happened next? What happened to the balloon? It started going down. So with the minus sign. How much is it going down by? Well, it's going down by a rate of 10 every minute. We don't know how many minutes are going to go by. There's our x. Okay? You're going to try one more example. I'm going to get you guys to pause it. Try this one yourself. See if you can figure it all out. It's the same question, just different graph. Okay, what is the initial cost to mail the package? What does it start at? What's our first nice point? Right there, $15. What is the rate per kilometer? Okay, it's a rate question. It means need another nice point that I definitely know. I think this one I know. Okay, and the reason I'm picking that one as opposed to this is I'd have to guess at the numbers. Okay, I want points I don't have to guess at, like point A on the last graph. And this one I definitely know is 120. I know that one for sure. Okay, it's my rate. Gotta erase some of these arrows, sorry, get rid of them. My nice dot. Okay, I need to go up, over, up. How much did I go up? I went from 15 to 20, so it's up 5. I went over. I started at 0 and I went over to 100. That's like this line right here, right? Over to 100. Okay, step 2, I got to take my words and replace them with units. $5 for 100 kilometers. Step 3, let's divide that. It's going to cost me 5 cents per kilometer. Okay, we need an equation to represent this relationship. Okay, x, the thing across the bottom is my number of kilometers. The thing up the side is my cost. Okay, my cost is always, well, what did my cost start at? We said our initial value is 15, and it's going to go up 5 cents for every kilometer. I don't know how many kilometers, I need an x in there. Oh, part D, how much would it cost to mail a package 120 kilometers? Well, I know how I can do that now. I can take my equation, but instead of writing the letter x in there, I know how many kilometers, specifically 120. Okay, we're going to do some bed math here. Always do your multiplying before you're adding. So 0.05 times 120 is 6. This is going to cost us $21. What if we had to do 300 kilometers? Well, it still costs 15 bucks. It's still 5 cents per kilometer, except for now we're going 300 kilometers. 15, and we get 30 bucks. Okay, there's rates. An old idea and a new idea. Sorry, an old idea in a new way. We're going to try this idea of rates, figuring out patterns off of graphs and how they're related to each other. Give this sheet a try. If you're stuck, come see me. We're going to work on this idea for the next little while, so we kind of want to get this one figured out.